Assalamualaikum warahmatullahi wabarakatuh to everybody, especially respected panels and my supervisor. My name is Aniq Syamil within the student ID of 2024650632. And today I would like to present my FYP with the title of Experimental Study on the Effectiveness of a Mass Spring TMD System in Reducing Structural Vibrations. This project focuses on reducing unwanted vibration in structures using a TMD. Moving on to the introduction, vibration is a very common problem in engineering structures and mechanical systems, as these vibrations could be source of element which are wind loads, earthquakes, machinery operation, and traffic loads. Excessive vibrations could lead to reduced structural lifespan, cause structural fatigue, create occupant discomfort, and increase maintenance costs. As modern buildings become taller and more flexible these days, vibration controls have become increasingly important. Therefore, engineers require effective methods to reduce this vibration and improve structural performance. Moving on, structural vibration remains a major challenge in the engineering world. When the excitation frequency approaches natural frequency of a structures, resonance can occur. Resonance causes a significant increase in vibration amplitude, which may lead to structural damage and safety concerns. Although various vibration control systems available, next we move on the objectives. This project has two objectives, which is objective one, to design and fabricate a mass spring tuned damper system, and second is to evaluate the effectiveness of the said TMD system in reducing vibration amplitude, reducing structural sway, and improving dynamic stability. Moving on, this is the design of the said TMD, which includes base, frame tower, and a platform. Moving on, I will explain to you guys on tune mesh damper. Definition of a tune mesh damper is a passive vibration control device consisting of mesh, spring, and a supporting structure. How does this tune mesh damper works? It works as it's tuned close to the structure's natural frequency. When vibration occurs, the MD move in opposite direction of the said vibration uh, to f- to counter the vibration, absorb vibration energy, and in the end reduce the vibration amplitude, which is the objective of the tune mesh damper. Next is real life application of tune mesh damper. Tune mesh dampers are widely used in modern engineering structures. One famous example is Taipei 101, which used a large tune mesh damper to reduce wind-induced vibration. As we know, this building is very massive and it needs the support of a TMD to stay strong. The MD systems are also used in bridges, towers, and industrial machinery. This application demonstrates the effectiveness of TMD technology in improving structure stability. Now, I will give you information on the project scope. The scope of this project focus on a scale building structure model. A tuned mesh damper will be installed at the top of the structure with different spring stiffness value and mesh configuration will be tested. The vibration response will be measured using acceleration and structural deflection data. Finally, the effectiveness of each configuration will be compared and analyzed. And this brings us to proposed design. This slide shows the proposed structure and tuned mesh damper design. The structures consist of base, frame tower, platform, spring, support rod, and mesh block. The TMD is placed at the top because this location is proven to be generally displacement during vibration. By placing the TMD at this position, vibration energy can be absorbed more effectively. Moving on, I will discuss on the methodology part of the project, which is explained through a flow chart. The methodology begins with a literature review to understand vibration theory and the TMD system, which the design of the mass spring TMD and the engineering analysis will be conducted before submitting to the supervisor. As the supervisor approve, the structure MTMD will be designed and fabricated. Experimental testing then will be carried out and the data will be collected using vibration sensors. Finally, the result will be analyzed and compared to determine the effectiveness of the TMD. Then we move to the experimental procedure. First, the structure will be tested without a tuned mesh temper first, and the vibration data such as acceleration and displacement will be recorded. Until then, the tuned mesh temper will be installed. The experiment will be repeated using different spring stiffness and mesh configuration. The collected data will then be compared with the baseline's results, which is comparisons between installed TMD and with the non-installed TMD. These comparisons will allow us to evaluate the vibration reductionist performance of the TMD. Next, we will move on expected results of the FYP, which it is expected that the tuned mesh damper will reduce vibration amplitude and structure sway. The acceleration response of the structure is also expected to decrease and improve dynamic stability. A shorter settling time is also expected, meaning the structure can return to a stable condition more quickly after the vibration. We move on to project significance of the project. Academic contribution, which is it demonstrate vibration control principles and provide practical understanding of the structural dynamics. From engineering comprehension perspective, passive vibration control solution and are useful for educational and laboratory applications. Last but not least, we will move on the conclusion of this project. In conclusion, structural vibration can negatively affect safety and performance of a building and its users. But this such a vibration is a very serious engineering issue. A tuned mesh temper offers a practical solution for reducing vibration, which is very effective to counter this particular problem. This project designs and experimentally evaluates a mesh spring TMD to know that how effective does this as a counter react to vibration. The effectiveness will be assessed through vibration amplitude, acceleration, and structural deflection measurements. Thank you for lending your ears to my FYP project. That's all for me. Thank you.